Hey guys, Mr. Fackenthal here again. Today we're going to be talking about Chapter 7, Section 2, which is all about finding cube roots. The last section was on finding square roots, and this is going to be kind of similar. So let's get right to it. So the key idea of this lesson is that a cube root of a number is a number that, when multiplied by itself and then multiplied by itself again, equals the given number. A perfect cube is a number that can be written as the cube of an integer. The symbol, which is a radical with a 3 on it, is used to represent a cube root. So a cube root would be something like this. We know that 3 times 3 times 3 equals 27. So the cube root of 27 is equal to 3. And this is also a perfect cube because it can be written as the cube of an integer. Alright, example 1 is titled Finding Cube Roots, and here they want us to find each cube root. Well, for A, we know that 2 to the third is equal to 2 times 2 times 2, which is equal to 8. Therefore, we know that the cube root of 8 is equal to 2. For B, the cube root of negative 27. Well, we haven't seen negatives yet, but we know that negative 3 to the third power is equal to negative 3 times negative 3 times negative 3. So a negative times a negative is a positive. So now it's a positive times a negative is a negative. So this will give us negative 27. So the cube root of negative 27 is equal to negative 3. And I'll change the color for our last one. We have the cube root of 1 over 64. So the cube root, we know that we can break this apart as the cube root of, the same property holds true, it'll be the cube root of 1 all over the cube root of 64. Well, the cube root of 1 is 1 because 1 times 1 times 1 equals 1. And the cube root of 64, we know that 4 times 4 is 16, times 4 is 64. So the cube root of 64 is 4. Therefore, our final answer is going to be 1 over 4. Cubing a number and finding a cube root are inverse operations. You can use this relationship to evaluate expressions and solve equations involving cubes, which we'll do on the next one. Alright, example 2 is all about evaluating expressions involving cube roots. So the first one, A, we need to evaluate the expression. We have 2 times the cube root of negative 216 minus 3. So how are we going to evaluate this? Well, the first thing we should do is look at the cube root of negative 216. We know that the cube root of negative 216 is going to be negative 6. Because negative 6 times negative 6 times negative 6 equals negative 216. So we simplify the cube root in the equation. That gives us 2 times negative 6 minus 3. Well, we know with order of operations we have to do the multiplication first. 2 times negative 6 is going to give us negative 12 minus 3. And then negative 12 minus 3 equals negative 15. And for B, we have the cube root of 125 cubed plus 21. But we know that cube roots and cubes are inverse operations of each other. Therefore, they're going to cancel out, which will leave us with 125 plus 21, which is equal to 146. Example 3 wants us to evaluate an algebraic expression. So they gave us x over 4 plus the cube root of x over 3, and they told us that x is equal to 192. So the first thing that we have to do is rewrite this whole equation and substitute in 192 anywhere that there is in x. So it would be right here and right there. So let's rewrite it. We have 192 all over 4 plus the cube root of 192 all over 3. Sorry, that's a little crooked. Now, when we simplify this, we have 192 over 4 plus the cube root of 192 over 3. That's going to give us, well, 192 divided by 4 equals 48. And then for this one, if we broke the cube up and did the cube root of 192 and the cube root of 3, we wouldn't get perfect cubes. So first, let's divide 192 divided by 3, which will give us 148 plus the cube root of 64. So from here to here, all we did was divide 192 divided by 3. So we have 148 plus the cube root of 64. Well, the cube root of 64 is 4. So we have 48 plus 4, which is going to give us a final answer of 52. Example 4 is our real-life application. We need to find the surface area of the baseball display case over here. The baseball display case is in the shape of a cube, which means all the sides are the same. Use the formula for the volume of a cube to find the edge length S. So we want to find out what the edge length of the cube is. And because a cube is the same on all 4 sides, all of these edge lengths will be the same. Now, if we didn't remember over here, the volume of a cube with the edge length S is given by the formula V equals S to the third. So our formula is volume is equal to S cubed. So now we just need to fill in our values that we know. So right now we have 125 inches cubed is our volume. So 125 is equal to S cubed. Well, to solve this, we need to do the inverse operation of a cube, which is the cube root. So take the cube root of S cubed, but whatever we do to one side, we have to do to the other. So let me take the cube root of 125. Well, we know that the cube root and the cube are inverse operations, so that's going to cancel out and leave us S. Then we have the cube root of 125, which is equal to 5. So each edge length is 5 inches long. Now they also want us to find out the surface area. They said the edge length is 5 inches. Use a formula to find the surface area of the cube. So over here they told us the surface area S is given by the formula S, which stands for surface area, equals 6 times S squared, which makes sense because S squared would give us one side, and there's 6 sides on a cube, which is why we multiply by 6. So let's plug in our values that we know. We have S is our surface area, which is what we're looking for, is equal to 6 times, we have 5 for our side length, for our edge length, squared. Well, we know S is equal to 5 squared is 25. It's going to be 6 times 25. And then we know 6 times 25 is equal to 150. So our surface area is going to be 150 inches cubed. Alright, don't forget to like and subscribe, comment below if you have any questions or bring your questions to class. And don't forget to turn on the notifications so you can be alerted every time I put a new notes video up for you. Alright, happy solving!